So on to section 7.3. We are rapidly completing this chapter. 7.5 is the last section of this chapter. So we'll have our first chapter exam next week. All right, so we'll have our quiz this week and our performance tests. That grades book is rapidly getting filled up. And if you thought the first semester went by fast, second semester goes by even faster. All right, so we looked in the last section at what it meant to have polygons that are similar. Okay? We looked and saw that this is a similarity statement. Triangle ABC is similar to triangle DEF. Right? So similar polygons have all corresponding angles that are congruent. And then they all have all corresponding sides that have an equal proportion, right? That are proportional. That equal ratio of corresponding sides is called our scale pattern. So we're going to focus our study on just triangles. And some of those ideas that we looked at in chapter 4 about triangle congruence are going to come up again today in this particular lesson. Does anyone remember the 5 different ways to prove two triangles are congruent? SSS is one of them. Side, side, side. Angle, side, angle. Side, angle, side. Angle, angle, side, and HL. Very good. So we know all of those. We're going to find proving triangles are similar are even a little bit simpler than those ones. All right, so we're given that these are similar. So what we know is all angles are congruent. So if angle E is a right angle, E goes with B. So they're corresponding. So angle B is also going to be 90 degrees. F and C go together. So we're given F is 51 degrees. So angle C also is going to be 51 degrees. And then A and D go together. So if A is 39, the measure of angle D also equals 39 degrees. All right, so our first similarity possible. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So now, instead of when we were proving congruence where we had to have a side as well, now we just need two angles. If I know two angles of one triangle are congruent to two angles of another, those two are similar. Why don't we have to know all three angles?
To transfer it to the other ones?
Why isn't it AAA instead of just AA?
You don't need three angles because two angles are bigger than the third.
Very good, Lacey. Lacey remembers the third angle theorem, right? If two angles of one triangle are congruent to two angles of another triangle, then the third angle has to be congruent. So we can just use angle, angle. So let's look at this one. Let's see. Determine whether you could prove the two triangles are similar. All right, so we have this big one, and we have this small. So, is triangle WVX similar to triangle WZY? Well, do they have angles that are similar? Well, let's look. If I go ahead and separate these two, I have WVX. We know that that's a right angle. And then I have there we go. WZY. And that's a right angle. Let's think about this. They overlap on W, so those guys are congruent. So angle W is congruent to angle W by the reflexive property. And angle WVX is congruent to angle Z because all right angles are congruent. Therefore, triangle WBX is similar to triangle WZY by angle A. Yep. Let's look at these ones. So these arrows in the same direction means parallel. I'm going to go ahead and extend these so I can go ahead and identify what angles are corresponding. Hey, so those guys are corresponding angles. And then let's look at these ones. These two are corresponding angles of the other one. So are these similar? Yes.
Sir.
They are similar.
Oh, yes.
We have two angles of one triangle. We want the two angles of the other. Those guys are similar. All right. So first, let's look. Are these triangles similar? We have vertical angles and then right angles. So we have
Similar.
two angles of one triangle, similar to two angles of another triangle, or congruent to two angles of another triangle. So those two triangles are similar. So let's go ahead and set up a proportion and solve. Take one triangle, both on top, and then the other triangle, both on bottom. I just need to make sure I line up which one goes with which one. So what goes with the X? The 6. The other one over there. Simplify and solve. Divide top and bottom by 5. 4 over 3.
Oh my God.
Switch places with those guys. 3 over 6 equals 4 over X. Simplify there. 1 and 2. Cross multiply. X equals 8. See if you can solve the next one.
Yeah.
Set up that next one and solve. All right, here we go. So again, these are similar. We have vertical angles. We have one congruent angle that's 65, and then we have our vertical angles are congruent. So these guys are similar by angle. And then let's set up our proportion. Take one of these, put it in the top. And then which ones of these ones do I need to use? So first, I guess the 25 is easy. That's going to go with the 35. And then which one of these two is going to correspond with the X? Well, this blank one to the vertical, that's going to be the 45. Now let's reduce and then cross multiply. Divide top and bottom by 5. 7x equals 45 times 7. Or 45 times 5, my bad. 225. Divide both sides by 7. X equals 32.1 centimeters. All right. Moving forward. So while there was 5 congruence postulates in chapter 4, there's only 3 similarities. Right? We have angle, and then we're going to have side, angle, side, and side, side, side. The only difference is now we're not showing things congruent. We're showing those sides are proportional. We need to do that extended ratio. So let's look at this one. We wanted to determine which of the triangles are similar. So let's go ahead and create an extended ratio between them. Let's do ABC and DEF first. Remember how we go ahead and do that. What we're going to do is this black one, smallest to biggest on top, 6, 9, 12. And then this one, smallest to biggest on bottom, 4, 6, 8. Remember, you can use your calculator. You can divide the top by the bottom. If all the decimals end up being the same, you're good. Or you can reduce. Divide top and bottom by 2, you get 3 over 2. Divide top and bottom by 3, you get 3 over 2. Divide top and bottom by 4, I get 3 over 2. These are all the same, right? So triangle ABC is similar to triangle. Let's see which one goes with which one. So what goes with A going to be the F, E, and those two are similar. And let's check the other ones. Check the other ones. Let's check ABC and this big one, GHI. So the first one and the last one. So again, 6, 9, 12. And then 6, 10, and 14. Are these all congruent? Are these equal? No. So these guys are not similar. And then let's do this one and this one. So we have 4, 6, 8, and then 6, 10, 14. Let's reduce these. Divide top and bottom by 2. Those guys are not similar as well. So we're checking those extended ratios. All right, let's look at these last ones. Remember, we're just using side, 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 angle, side.
Whoa, that's right.
All right. So I know that angle, so I'm using one of these three. Side, 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 angle, side, or angle, angle. So I have one angle for these guys. If I'm looking at this triangle, and then this entire triangle, they share angle S. Angle S is congruent to angle S by a reflexive property. So now let's see if these sides are proportional. What's the length of this entire side? 4 plus 12 is 16. So let's see if we have a true proportion. Let's use side angle side. So in the top here, 4 and 5. What corresponds with SP? That 4? SR. So 16 and 20.
16.
This is the entire length of the side, 4 plus 12. Simplify. We have 1/4 equals 1/4. And angle S is congruent to angle S. Let's write our congruence, our similarity statement. This is our statement. Triangle PSQ is similar to triangle RST by side, angle, side. Next one. I have two angles of one triangle. I want to figure out what the measure of angle C is here. So we have measure of angle C equals 180 minus 72 minus 41. Let's see what we do. I get measure of angle C equals 67 degrees. And then if that's 72, that's 67. This has to be 41. So triangle ABC is similar to triangle FDE by angle, angle. Okay. Have all three angles of one triangle. We can go to all three angles.
This is what
second is this.